In this problem, we're going to analyze the graph of a function by answering a series of questions. Here's the graph that we're going to analyze. The first thing that we want to do is recognize that this is in fact a function because it passes the vertical line test. What are the intercepts of the function? Well, the x-intercepts are -2 and 2. The y-intercept is 3. If we just want to say what are the intercepts, we would say -2, 0, 0, 3, and 2, 0. Notice the difference. If I specify x-intercepts, I only need to provide the x-coordinate. If I say intercepts in general, I have to say an ordered pair. Next, I want to determine the domain of the function. You could think of the domain of the function as the set of all x values for which the graph exists. This graph exists from x equals -4 to x equals 4. For that reason, the domain is the set of all x from -4 to 4 inclusive. What's the range? The range can be thought of as the set of all y values for which the graph of the function exists. The graph of this function exists for y equals 0 all the way up to y equals 3. For that reason, the range of the function is the set of all y from 0 to 3 inclusive. Finally, we want to know whether this function might be even, odd, or neither. When we talk about that, what we want to do is really look at, is the graph of the function symmetric with respect to the y-axis, or is it symmetric with respect to the origin? If the graph of a function has symmetry with respect to the y-axis, then the corresponding function is said to be even. We can see here that 4, 2 is on the graph, and so is -4, 2. 2, 0 is on the graph, so is -2, 0. In general, if xy is on the graph, so is -x, y. For that reason, the graph has symmetry with respect to the y-axis, so the function is even.